Hello and welcome to this video on types of chemical reactions. We're going to take a look at a variety of different types of chemical reactions, actually 5 of them, that are some basic reactions that everybody should know. And so we see here there's a combustion reaction. Actually, this is a thermite reaction. We'll talk about thermite a little bit later on in the year and exothermic and endothermic reactions, what's going on with that heat. But right now we're just going to keep it to the basics of what you actually see in each reaction. Today's focus is going to be primarily on the first 3, and then the second 2 we'll actually get to a little bit later. So grab your notes, your notebook, and something to write with, and let's get started. So the 5 types of chemical reactions that we primarily work with, and just kind of the basics, so there's more to it than just this, but the first one is going to be synthesis, okay? And so synthesis or synthesizing means to put together, and so we see that we're putting 2 things together here. Decomposition is decomposing or breaking something apart, and so here we see that we're breaking this apart, and these are kind of generic symbols for these chemical reactions. Combustion, I think of most oftentimes is when we're burning something, and whenever we burn a carbon-based compound, we end up producing water and carbon dioxide. And so that's a characteristic, and we'll talk a little more in depth. So these 3, synthesis, decomposition, and combustion, are really the focus of today. And then we'll do 2 additional videos, one on single replacement reaction. So I'll introduce it to you today just so you have a basic understanding. And then double replacement as well. And so these ones are replacing. So we have something that's going to be replace the other, or sometimes you'll hear displacing. Okay, so single displacement or double displacement. No matter what, we're actually going to be swapping some things around. So let's take a look at synthesis first. So synthesis, like I said, is combining. I think in your textbook it actually says combination reactions or something to that effect. And so combining 2 or more chemicals, so I have this generic, we're just combining 2 things to form one compound. And so we're combining this. If you think of photosynthesis, we're actually making something. So this is putting these things together. And so a lot of times this is how we actually form compounds. And so we're going to take a look at these today and see some examples. So one of them that we've already taken a look at is going to be when we form water. So we take H2 plus O2 and we form H2O. Now remember, whenever we write these, we actually have to go through and balance them. We've balanced this one a couple times already, so we know that we need a 2 here and a 2 here. We can see some other ones. So for example, if we want to form salt, so Na plus, remember Cl is actually a diatomic molecule, so Cl2 will go through, and when these 2 combine, we're going to actually end up producing sodium chloride. Now, sodium, remember, has a +1 charge, and chlorine has a -1 charge, so we have to remember how to put together those ionic formulas, so NaCl. Now I have to go back and balance them. I have 2 chlorines here and only 1 over here, so I'm going to put a 2 in front of this. Now that gives me 2 sodiums and 2 chlorines. I have 2 chlorines over here, but I only have 1 sodium. So I'm going to put a 2 in front of the sodium, and that is actually balanced. Okay. We can see these in a variety of different ways. And so if you were to see anything that's just going to give you 2 things on one side, so say we have magnesium and oxide, or an oxygen that are forming. So if you see something and there's 2 individual elements in this class in particular, you can assume that they're just going to be combined. And in this case, we get MgO. We have a 2 plus and a 2 minus charge here. And so then we have to go through and balance our equation. Okay? And those are synthesis reactions. And they actually occur quite frequently in many respects. So the opposite of a synthesis reaction is a decomposition reaction. This is where we're actually going to break them apart. So we start with a compound and we break it apart into its components. And it can be 2 or more. Most of the time for our purposes it will be just 2, but it could be more than 2 chemicals that we break it apart into. And so the opposite of that would be, well, if we had H2O, we're going to break that apart into H2 plus O2. Remember, those are diatomic molecules, and we want to make sure that we go through and balance our equation. Or we could take that sodium chloride. So if you see NaCl or you see anything that is just one compound on the left-hand side of the equation, we know that the only thing that we can do is break it apart. And so that means we're going to end up with sodium plus, and remember, Cl is a diatomic molecule, so we want to have the Cl2 here. Okay, same thing with the magnesium oxide. Okay, if we see just one thing on this side of the periodic or on the equation, we know that all we can do is break it apart. So we're going to have magnesium plus oxygen, which is an O2. Now be careful, we only put the 2 if it is a diatomic molecule, and so if you don't remember which ones those are, go back and check. It's going to be H2, N2, O2, Cl2, F2, Br2, and I2. So these are all of the ones that are going to form those diatomic molecules. I keep going over that, hoping that you'll remember. Okay, let's take a look at combustion reactions. I think a lot of people get very excited about combustion reactions because, well, there's lots of lights and lots of heat. So most of the time, we think of this as burning a carbon-based molecule with oxygen to form carbon dioxide and water, and that's what I really want you to focus on. We're going to talk about another example in a moment. So this could be a carbon and a hydrogen together. It could be just carbon. It could be carbon, hydrogen, and oxygen together. Actually, usually have to have carbon and hydrogen of some sort because we have to have the hydrogen in the water there. And then we see that it's going to be in the presence of oxygen, and this is the big deal right here. If you see something being combined with oxygen on the reactant side, okay, only on the reactant side, then we know that it's going to be combustion. So if oxygen is a reactant, it's going to be a combustion reaction. If it's reacting with a carbon-based molecule, we're going to form H2O and CO2 always. That is just one of those beautiful things that we consistently see in nature. The other example that we're going to see here is that sometimes we have synthesis reactions with a metal and O2 that forms a metal oxide. And so we just saw an example of this. I'm going to show you a couple examples here in a moment. So again, O2 is a reactant. If O2 is a reactant, if it's on the left-hand side of that arrow, then we know that it's going to be a combustion reaction. I actually usually like students to call this synthesis, but it's both synthesis and combustion, and so either one of them would technically be correct. All right, let's take a look at a couple of examples, and I think these are one of the more challenging things for students to be able to balance for equations. So say we take methane. Methane is CH4, and we add it to O2. So if you were to see this on a piece of paper, or a quiz or a test, excuse me, then we know that as soon as we see the oxygen here, that we have to, in a carbon-based compound, it has to form CO2 and H2O. Okay, now I have to go through and balance this. So again, I'm going to use that method that we've been working with. So we have C, H, and O on this side, and we have C, H, and O on this side, and I want to do my inventory first. So on this side I have 1 carbon here, I have 4 hydrogens here, and I have 2 oxygens. Okay. Over here, now this is where it gets tricky. If you see that they're in 2 different compounds, okay, so I have 2 oxygens here plus another oxygen here, which gives me a total of 3 oxygens. That can be problematic when we get to these because we see that it's split apart. Okay, we have 1 carbon and we have 2 hydrogens. So what I do first, and there's a variety of ways to go about these, there's not a wrong or a right way, but usually what I like to do is I like to make my odd number even if I need to. And since I have 4 hydrogens over here and 2 hydrogens over here, I'm going to start off by putting in my coefficient of 2. Okay. And when I do that, now I'm going to have 4 hydrogens. 2 times 2 gives me 4, and 2 times the 1 oxygen here gives me 2 oxygens here plus the 2 that I have here. So you have to go back and count them up in both compounds again, and that gives me 4 oxygens. Okay. I have 1 carbon still on both sides, but I have oxygens are different. Well, I can come back and at the end, this thing that's by itself, this oxygen by itself, I can actually go ahead and put a coefficient in of 2 here. And when I do that, I end up with 4 oxygens. And this is actually balanced. And so you'll see a variety of these. The other example could be that magnesium magnesium oxide. So we had our Mg plus O2 that formed MgO. Not OMG, MgO. And so in this case, I'm going to balance this. I have 2 oxygens here. I have 1 here, so I put a 2 in over here. Okay, and that gives me 2 magnesiums and 2 over here. So technically, because oxygen is a reactant, that this is going to be combustion, but I usually call those synthesis rather than combustion, but they're both. All right. So moving on, let's talk about single and double replacement reactions. So when we take a look at these, we see that single replacement is going to replace one thing. So single replacement, we have something that's by itself that's being added to some sort of a compound, and it actually is going to replace. So if it is a cation, it will replace the cation. If it is an anion, it will replace the anion. This is actually a cation example. And so we see that it will replace the cation. In a double replacement reaction, we see that they swap partners, okay? And so A was with X, and then X became A's X, and A ended up forming with Y, and then B was with Y, and B actually ended up forming with X. This looks like some sort of high school dramedy going on here, okay? So we are going to look at these a little more closely later on, but I'll give you an example of each so far. So we'll take something like, let's see, sodium plus, let's see, iron chloride, FeCl2. We'll make it iron 2 chloride, okay? This is usually always a solid for us, and this is going to be aqueous. Now that will change if it's a cation example. So this is a cation example. We'll look at both later on, okay? And what happens is that sodium is a cation, so it will replace, or it's a metal, it will replace the metal in there. And so we end up with NaCl plus Fe. And then I need to balance this, so in order to balance it, I'm going to put a 2 there and a 2 here. And you can go back and double check that or work it out on your own if you want to see how I balance that. Okay, when it comes to the double replacement reaction, we will see something like, say we have lead, nitrate, NO3, 2, we'll do lead 2, and this is usually always aqueous, okay, and we're going to add it to another aqueous, so we're going to have sodium chloride, which will be aqueous, and these will actually swap partners. So now what's going to happen is we're going to end up with lead forming with the chlorine, and then sodium forming with the nitrate. Now the cation is always going to go first. So we're going to end up with NaNO3, which is actually still going to be aqueous, and we'll learn that a little bit later on. And then the PbCl2, okay? And so to balance this one, I'm going to have a 2 here and a 2 here. And again, this one here will be a solid, and actually this one will be aqueous. And you'll learn a little bit more about that later. Just wanted to give you an example of each one of them so far, and then be sure to tune back in for additional videos on how to determine a little bit more information about single and double replacement. So those are the 5 reactions. We have synthesis, decomposition, combustion, single replacement, and double replacement reactions. And you want to focus on those first 3, so synthesis, decomposition, and combustion, and then we'll come back and take a look at these last 2 again later. That's all for now.